Smiley here. So today we will be discussing and learning about the real number system. So the real number system is a system which we generally use in our mathematics, okay? And it constitutes of the following. First is the natural numbers. Natural numbers are those which are 1, 2, 3, 4, and so on. These numbers are generally used for our counting, right? So they constitute the natural number set. Then there is the whole number. Whole number is also natural numbers only, but it includes the number 0. So 0, 1, 2, 3, 4, and so on and so forth. Integers are also whole numbers, but they include the negative values. Okay. So are basically our entire number line. So minus infinity, from minus infinity till something something till minus 3, minus 2, minus 1, then 0, then 1, 2, 3, so on till infinity. Now, then there is Q. Q here represents rational numbers. Rational numbers are those numbers which can be written in the format of P by Q, okay, where Q is not equal to 0. Okay, so it can be any number, say 2 upon 5, right? 3 upon 5, minus 11 upon 5, any number. It's number of this sort, which are called rational numbers. Okay, now then there is QC. This QC here is irrational numbers. Irrational numbers are those numbers such as pi, e, and so on. Okay, these numbers in nature are non-terminating and non-repeating. What do I mean by that? Let's look at a simple example. Say if you have 2 upon 5, this will be this will be 0.4, right, in decimal format, and 1 by 3, this will be 0.3333 dot dot dot, right, till infinity in decimal format, and this will be 0.4. If you look here, this terminates, that it doesn't continue. And this right here, what does this do? This doesn't terminate, but this has a repeating pattern, and that's why we can represent it in this fractional format. Okay, but these numbers, they cannot be represented in the P by Q or fractional format, as they are non-terminating, which means they do not terminate, and they are also non-repeating, which means that they do not have a fixed pattern. Here you can see there is a pattern 33333 after every number, but they don't have something like 33333 after every number. They have random numbers such as 3.1. Let's take pi value only, 3.1415, some and so on, right? Now this all number systems together make our real number system. Real number system includes all of this, okay, all of this. So now we will be looking at a property of irrational number. So let's say you have an irrational number a plus b root x, okay, where root x is an irrational number. Now the property of this is that if you take this plus and if you multiply it with the opposite of this, so a minus b root x, it will always result in a rational number. Okay, now the conditions for a and b is that both of these numbers must be rational. Okay, they must be rational. Okay, that's a very important condition. So they must be able to write in the format of p by q. Okay, that's the first condition. Now let's look at some further things. We will now look at LCM and HCF. So what is HCF? HCF is the highest common factor. So let's say I have a number a 8. Okay, 8. It's not looking like 8. And I have 9. So if I ask you to list down it, there are factors. You will say that the factors is what? 2, 4, 1. This factor is 3 and 1. Now, highest common factor is basically asking the factor which is the highest or the greatest in between two numbers, which in this case it is 1. Okay. Now LCM. LCM, let's take 2 and 3. Now LCM is asking that what is the multiple or what number is the will be the least value. What is the least value when 2 is multiplied with something and 3 is multiplied with something to get the same number here. Okay, so both of them should become same. Okay, in this case it's just 2 and 3. Okay, when they are both multiplied with each other you get the 6. So that's LCM. Now let's look at something. Okay, now let's look at something. If you take HCF of A comma B, means two numbers, and you multiplied them with LCM of two numbers of the same numbers, right? It is the same thing as AB. Okay, AB. If you multiplying two themselves. Okay. Now, if you want a reason why, we can say that A comma B, the highest common factor is 1. Okay, highest common factor is 1, and that AB, this AB which is here, we can say that since HCF was 1, right? If you will notice, if HCF was 1, there's no other multiple which is lowest. So, what this means is that these two numbers multiplied with themselves, so A multiplied by B is the same thing as A multiplied by B. So, A multiplied by B is A multiplied by B, right? So, that's just a simple proof. Let's look at an example now. Now, take a look at this question. You have been given that HCF is 4, LCM is 3, and that one of the number is 2. We have to find the other number A. So, by using the property HCF into LCM, right? HCF into LCM is equal to A into B. We will apply this property right here. So, 4 into 3 is equal to A into 2. Okay, so A is equal to 12 upon 2. A is equal to 6, which is our answer. Now, we will be looking at proof for irrational numbers. Okay, so if there was some root 2 or some root x, right? Root x, we don't really know. And if I were to ask you that how do I know that there is no such number p by q, right? There is no such number p by q for root 2, right? It's not a irrational number, it's a rational number. If I ask you that, so how will you prove it? That this root 2 or any root x where x is a prime number. Okay, so for a prime number, the square root will always be irrational. Okay, so if I ask you that if there is this root 2, okay, and I want you to prove it to me that this number right here is irrational, how will you do it? So what we will do here is we will use something called proof by contradiction, right? Means we contradict, right? We contradict ourselves all the time, right? We say something, we do something else, right? Similarly, we will use that same logic right here. What I will say is that let's say there is some number, okay, p by q is root 2, right? It can be represented in this format. Okay, now what I will do is I will square this, so this will become p square is equal to 2q square. Okay, I just threw the q there and then I squared it. Okay, I will just show it here. P is equal to root 2q. Now what this means is that p square is here and it's equal to 2q square. Okay, what I am assuming is that p by q here, p by q are co-primes. They are co-primes. Coprimes means that coprimes are those numbers which have HCF 1. So P by Q's HCF is 1. So they are coprimes. I'm just assuming that. So they are non-irreducible. Now, if I take this fellow down, P square upon 2 is equal to Q square. And if you think about it, right, let's not even do that. We can use this only as our reference. Now, what I was saying was that from here we can see that 2 which is there, it P, right, 2P there is there. So what this means is that P is divisible by 2, which means that 2 divides P. Now, why does 2 divides P? Because if you think about it, what we had assumed that Q does not divide. So Q square also won't divide. If Q square doesn't divide, that means that P2 only divides, because there are two factors here, right? There are two factors here. 1, Q, and this itself. So what this means is that 2 divides P square. If P square is divisible by 2, right? If P square is divisible by 2, P is also divisible by 2. Okay. So P is also divisible by 2. Okay. So from here, we can say that 2 is a factor of P. Okay. So this is one thing what we have obtained here now. So now what I will say is that P is equal to 2C. Okay. C is some multiplying factor, right? Because obviously, if it is divisible when I divide P with 2, right? When I divide P by 2, I will get some C, right? C can be anything, 1, 2, 3, anything, right? So that's that. And I will substitute this fellow here. So what I will get here is 4C square. 4C square is equal to Q 2Q square, or I can say that 2C square is equal to Q square. Same logic carry forwards here. So what this means is that Q is also a factor of P, right? Q is a factor of P, but Q is a factor of Q. But what we had assumed was the HCF P by Q is 1. If HCF is 1, that means there is no other factor which would be common in them, right? But there is a factor which is greater than 1, and that too is common in P and Q. What is that factor? 2. Since 2 is common in both of them, we can say that this is not possible, hence proved. Okay, hence proved that root 2 is irrational. Okay, and that's our proof.